Welcome to The Explainer. Today we're diving into a process that nature has been perfecting for billions of years and that we've harnessed to change our world. We're talking about distillation.
So, let's start with the big question. Think about it. Our planet is covered in salty oceans. So how on earth does that salty water turn into the fresh, pure rain that falls from the sky? It seems kind of like magic, but it's pure science.
Well, the answer is that our planet is basically one giant purification system. And the really cool part? We figured out how to copy that exact same natural process, to shrink it down and use it in the lab.
So, let's start right there, with the biggest water filter you could imagine, Earth's own water cycle. It's the perfect way to understand everything we're about to get into.
It all really boils down to two key steps. First, you've got evaporation. The sun heats up the ocean and the water turns into vapor. Now here's the crucial part. All the heavy stuff like salt gets left behind. Then that pure water vapor rises up, gets cold, and boom, condensation. It turns back into liquid water and falls as clean rain.
So, how do we take that massive planetary process and shrink it down to fit on a lab bench? Let's zoom in and see how we copy nature's trick.
This whole process has a name, of course. It's called distillation. And really, it's just a fancy word for separating things by boiling a liquid into a gas and then cooling that gas right back down into a pure liquid. It's the exact same idea as the water cycle, just in a much more controlled setting. So at its heart, all we're doing is forcing these two changes of state to happen. We use heat to boil the liquid into a gas, and then we use cold to condense that gas back into a pure liquid, leaving all the impurities behind.
All right, let's make this real with the classic lab experiment, taking salty water and making it completely pure, just like nature does.
To pull this off, you just need a few key pieces of gear. You've got your flask to hold the salty water, a Bunsen burner to provide the heat, a beaker to catch what comes out, and the real star of the show, this thing called a condenser. That's the key part.
And the process itself is just wonderfully logical. Step 1. We heat up the salt solution till it boils. Step 2, as it boils, the water turns to steam, but the salt stays put in the flask. Then that pure steam travels into the condenser, which is really cold. And finally, the cold makes the steam turn back into drops of pure liquid water, which we can just collect in our beaker.
So this condenser is the really clever bit. It's basically a tube for the steam that's surrounded by a bigger tube or a jacket that has cold tap water constantly flowing through it. This super cold surface is what makes the hot steam instantly turn back into a liquid. It's incredibly efficient. And that pure water we collect at the end, it has a special name. We call it the distillate. So in this experiment, our distillate is perfectly pure, totally drinkable water.
Okay, but here's the thing. Distillation isn't just for separating a solid, like salt, from a liquid. You can use it for something that seems way more complicated, separating two different liquids that are mixed together.
So a perfect real-world example is separating ethanol, alcohol, from water. If you mix them together, they look like one clear liquid. How in the world could you possibly separate them again?
The whole secret is hidden in their boiling points. See, ethanol boils at just 78 degrees Celsius. Remember that number.
Because water, of course, boils at a much higher 100 degrees Celsius, and that difference is our secret weapon. If we heat the mixture to, say, 80 degrees, the ethanol will boil off as a gas, but the water will stay behind as a liquid. We can just capture that ethanol gas, cool it down, and we've separated them.
Now this brings us to a really important distinction. The saltwater experiment we talked about, that's called simple distillation. But when you need to be really precise and separate liquids with different boiling points, you use a more advanced method called fractional distillation. And believe me, this isn't just some neat lab trick. Fractional distillation is one of the most important industrial processes on the planet. It's exactly how we take crude oil, which is just a messy gunk of hundreds of different liquids, and separate it into all the useful fuels that run our world, like petrol and diesel. It is absolutely essential.
So, all of this leads to a pretty logical question, right? If distillation is so great at turning salt water into fresh water, why don't we just build giant plants and solve the world's water shortages?
Well, it turns out there are some pretty major hurdles. First, boiling billions of gallons of water takes a truly staggering amount of energy, which makes it incredibly expensive to do on a large scale. And then you have to think about the waste. You're left with this super salty, concentrated brine. If you just dump that back in the ocean, it can cause a lot of damage to marine ecosystems.
So distillation is this incredibly powerful tool, a direct copy of one of nature's own amazing cycles. It lets us separate the useful from the useless. And that leaves us with one final thought to chew on. What other clever ways, from simple filters to complex chemistry, have we invented to sort through and make sense of the messy, mixed-up world all around us?